Hey folks, today I'm going to add another video to our series. This one is a gravitational field intensity question looking at a satellite orbiting the Earth. So I'm just going to I'm going to read the question. We'll go through some points, write down our givens, and solve this question. All right, so a satellite is in orbit above Earth at a height of 75 kilometers above the surface. What is the gravitational field intensity at this height, and what is the mass of the satellite if it feels a force of 2,500 newtons at this height? And see what is the direction of the field and the force. So we've got the Earth, and we got a satellite flying above the Earth, flying, and we know that it has a certain height above it, 75 kilometers. So let's see what we have. So let's information we have. We know the height is 75 kilometers. Which is the same as 75,000 meters. We don't usually work in meters. We usually work in meters, so we don't work in kilometers. And we want to know the G at this spot. And we have the height. So we're talking about Earth. And I didn't write the values down in the question, but you can look them up. And the radius of the planet itself is 6.38 times 10 to the 6 meters. And the mass of the planet, the mass of Earth, is 5.98 times 10 to the 24 kilograms. And I want to know G. So if you look in your formula page, you have your values. You have two formulas for G, gravitational field intensity. And the first one is G equals Fg over m, but we don't have the force in this one. We do in part B, so we'll look at it then. And we also have G equals G times the mass, and this would be the mass of the planet, over the radius. And this radius is the distance from the center all the way out to where the satellite is. So that's my R. So the radius is equal to the radius of the planet plus the height. So the radius is equal to 6.38 times 10 to the 6 plus 75,000, which gives me a radius of 6.455 times 10 to the 6 meters. And left all the decimal places because these are all values that are given. So I'm not going to round those off because it'll throw my answer off a little bit. So G and let me move these over a little bit because G and all that numbers are big. So G is equal to 6.67 times 10 to the negative 11. Still not enough room. Times the mass of the planet, which is 5.98, times 10 to the 24, all divided by 6.455 times 10 to the 6 meters. And this is all squared. So I put that in my calculator, crunch the numbers, and I should get a value of around 9.57 newtons per kilogram, which to me seems reasonable, since on the surface it's 9.8, and the further we get from the surface, the weaker that field intensity is. So that answer seems logical to me. So that's a decent value. Part B, the question asks, what is the mass of satellite if it feels a force of 2,500 newtons at that height? So I want to know the mass of the satellite. So I have two choices. I can use the FG formula or the other G one. I'm going to use the other G one because it's pretty straightforward. Not a lot of variables. So it's FG divided by the mass. Remember that when you're using the formula with the more variables in it, the bigger formula, I guess, for lack of a better term. Excuse me. I use the bigger mass, and if I'm using the one with less terms, I use a smaller mass. So at this point, the field intensity is 9.57. The field intensity is 9.7, sorry, and the force is 2,500, and the mass is unknown. These two switch spots, and I find the mass to be a little over 250, so 261.23 kilograms is what I have that worked out to. And of course, you write a statement. I've already written it out. I'm going to drag it over here, and there's not a lot of room. I'm going through my work here, but you can see that. Gravitational field intensity, 9.57 newtons per kilogram. and the mass is 261.23. And the last question was, what is the direction of the field and the force at that point? At that point, the field and the force are both inward towards the surface because the object is being pulled downward. All right, hope that helped. Any questions? Hop in and see me. Thanks.